Good morning all. In the last session we have discussed about the introduction to database. There we have seen what is a data, we have seen the definition of data, definition of database, and also seen the database management system. Okay. After that we have seen the characteristics of database. There we have seen 4 points there. Okay. So now we are going to discuss the advantages and disadvantages of DBMS in detail. So first we can discuss the advantages of database management system. The first one is controlling redundancy. So what do you mean by this concept redundancy? Redundancy is nothing but repetition. Okay, by implementing the DBMS concept, we have reduced the repetition of the information. So repetition in the sense, we don't need to have the same copy of the data supplied to everyone. We can use the same copy of the information or the data, and that data can be shared to each and everyone. Okay, that means that it's the same copy can be accessed to each and everyone. In that case, data redundancy will not happen. So before the implementation of database management system, we had a concept, or we had a technique called the file processing system, traditional file processing system. So in traditional file processing system, each and every user will be maintaining the same copy of the file. Okay, this is the first point they are saying, that in traditional file processing system, each and every user maintains the copy of the same file. But in DBMS, the same copy can be shared among many users. Thus, redundancy can be avoided. Okay, but in the concept of DBMS, we can share the same information to different users. Okay, so thus we can reduce the redundancy. Let us see an example. This is the representation for a traditional file processing system. Okay, so here we are having 3 users. Say, for example, this may be this may be a teacher, this may be a HOD, and this may be an administrative staff. Okay, this is the database in a college. In a database, there is a college. In a college, there is a database called the student file. So this student file, in traditional file processing system, this student file is being shared to everyone. The copy of the student file is given to everyone. Okay, this is the first copy, this is the second copy, and this is the third copy. Okay, so the student file, this database or this file is having replication. This file is having replication, and that replicated copy is given to the teacher, the HOD, as well as the administrative staff. Okay, this was the major disadvantage in traditional file processing system. Okay, but in the case of database management system, what happened? We maintained a database. In that database, we had that student file. Okay, that student file is being shared to each and every user. This means that we are having only a single copy of the data. This single copy can be accessed by a teacher, and a HOD, and an administrative staff. Okay, so this is the advantage of database management system. Okay, what is that? The redundancy is avoided. Okay, so this we don't have to take the copy and give to everyone. Instead, we can have a single copy and share it to multiple persons. Clear? So this is the concept of controlling redundancy. Okay, in examination you don't have to draw this figure. This figure is just for explanation purpose. Okay, in examination you don't have to draw the figures. You have to just mention the points. Okay, I will repeat the point once more. In traditional file processing system, every user maintains the copy of the same file. Okay, understood? But in DBMS, the same copy can be shared among many users. Okay, the same copy can be shared among many users. Thus, redundancy can be avoided. Okay, so this is the major advantage of DBMS. Okay, first advantage is this one. Let us see the second one. Restricting unauthorized access. See, I have told that the same file is being shared to everyone. I have already told that. Okay, but the same file, all information is not required. All information is not required for everyone. For example, the teacher does not need the fee details. The student file may be having fee details, but the teacher does not need the fee details. Okay, HOD does not need the phone number of the student. Okay, because the phone numbers and this conversation with the students are done by the staff advisors or the teachers. So HOD does not require the phone number. Now administrative staff does not require the marks. They require only the fee details. So we can hide certain details from certain users. Only the relevant details can be given to a particular user. Okay, so that is called restricting unauthorized access. So unauthorized access can be controlled. Clear? So this unauthorized access actually happens when multiple users share the same data. Okay, so that is what is saying. When multiple users share a large database, it is likely that most users will not be authorized to access all information in the database. In that particular database, all the users need not access all the informations. Okay, they don't have the authorization to access all the information. They will be authorized to access only a particular information that is meant for them. Clear? A very best example is this one. A financial data is confidential. Only the authorized persons are allowed to access such data. Clear? In bank and all, many financial data will be there. Okay, so the bank will be having a huge database. That huge database, lot of informations will be there. A clerical staff need not have to deal with the financial data of the bank. Okay, they can do various other jobs. Clear? So such information can be hidden. Financial details can be hidden from those persons. Okay. So I have also given some another example. Look at here. We are having three users: student, teacher, and parent. Okay. Now we are having a database called a student DB. Student DB means database. Okay. So here, the student need not want to access the phone numbers. This is a student, and the student need not want to access the phone numbers. Okay, so he can access the name, roll number, name, department, and his marks. Clear? So the student, he can access this much information. Okay, the student can access only this much information. The fee details will be hidden from the the phone number. The student can access the roll number, name, department, and CGPA. Okay, this much information can be accessed by student. The rest of the information can be, the phone number and the fee details will be hidden from the student. Okay, similarly, this teacher can view what all informations. Teacher can view what all informations. Teacher can view the same, the roll number, name, and phone number also he can view. Teacher can view this much information. What about parents? Parents can view what all informations. Parents can view the fee details, the name of the child, the department. Okay, this much information can be viewed by the parent. Okay, so this much information can be viewed by the parent. Clear? So rest of the information, that is the roll number, CGPA, and the phone number will be hidden from the parent. So the required information that has to be accessed by a particular person can be controlled using this mechanism. Okay, so the unauthorized users cannot access all the information. He will be allowed to access only the required information. Okay, so that is the point called restricting unauthorized access. Okay, hope all of you are clear with it. So this figure, I am again repeating that this figure is not mandatory. This is only for explanation purpose. Okay. The third point is providing storage structure for efficient query processing. So DBMS is a database is having a huge information will be stored in the database. So this database management system must be having a efficient mechanism so that we can easily store and easily retrieve the informations. Okay, easily retrieve the information. That is the main concept of DBMS. Suppose in the storage, in computer and computer storage, suppose we want to access a file. So what we do? We want to access the file called student.pdf. Okay, so we don't know where that file is there. Okay, it is very difficult to find because in our system we are having many files. So what we do? Normally what we do? We will select what? We will select we will search, we will select the search option and select for student.pdf. Okay, the same concept is implemented in database management system also. Okay, they are having an index structure. Using the index structure, we can easily search a particular file or search a particular data. Okay, so there are many techniques. There are many techniques embedded in DBMS so that we can easily store as well as retrieve information from the database or the disk. Okay, so usually database is stored in computer disk. Okay, hope all of you are aware about that. So the first point, DBMS provide a specialized data structure. It is having a specialized mechanism or a data structure and search technique to speed up the disk search for the desired record. Okay, so the desired record means record in the sense if we are using a table format, one row, a particular row is called a record. Okay, this is one record, this is another record, this is third record. So this table is having 3 records. So in order to search a particular record, we are having a specialized data structure and search techniques. Okay, so the specialized data structures and search techniques we will see in the 5th module. Okay, so what is that? What is the example of such data structure or such a search technique? That is called index. Okay, indexing technique is a main concept that is implemented in DBMS to have a speed up search and also to speed up data retrieval. Okay, this is an example for a indexing structure. Okay, so this is our database. This is our original database. Suppose we want to search the UP details. Okay, for that we are having a separate indexing structure is there. Indexing is there. So this indexing structure will tell where all locations the UP is found. Okay, so UP we are having another table. We are having this another table. This is called index. So this table is having 2 attributes. First one is the index value, as second one is the pointer. Okay, so the first value is UP. In UP and the second column, this pointer will tell in the original database where all UP is residing. So UP is having in this record. Okay, also Nepal is there here. UK is there here. Okay, if UP is found in multiple records or multiple rows, the pointer will also go to there also. Suppose we are having another row, another record. In that we are having the data UP. In that case, the pointer will point to that location also. In this mechanism, we can easily search or we can easily find a particular record in the database. Okay, so that is what it is saying. It provides a specialized data structure and search technique to speed up the disk search and decide to find out the desired record. Okay, such a technique is called indexing mechanism. Okay, now another concept is, in order to process the database record needed by a particular query, those records must be copied from the disk to main memory. So suppose you are going to access a particular record or particular data. For that, we will execute a query. Query means a question to the database. That is, for example, I have given an example here. See here, this table we have already seen, student database. So this is a large database, and this database is stored in the hard disk. This is our hard disk. In the hard disk, we have the database. So this database contains what? This student file or student database. Okay, so this hard disk contains this student database. Suppose a person want to retrieve the name of the student, only the name. He just want to know the name of the student. Suppose the principal want to know the name of the students in that college. Okay, so here the principal will execute this statement. This is the query. Select name from student. This is the query. Query means a question to the database. He will ask a question to the database. At the time of asking the question, what does it do? The database will execute the query and select that particular names, particular column, and it will be transferred to the main memory. Okay. Anyway the principal need to display that name. Okay. So that name will be transferred to the main memory. In the main memory, we are having a separate area called buffer. In that buffer, this details of the name will be temporarily stored. Okay, this is just for executing the statement. This is just for displaying the names of the students. Okay, this is the concept. Okay, that means that we are having a database, large database. From that, we can have a small portion to be displayed. Okay, for selecting that small portion will be temporarily stored in the main memory, buffer found in the main memory. Okay, that is the concept. That is the concept of buffered storage. Okay, that is the explanation for that thing is given. In order to process the database records needed by a particular query, those records must be copied from the disk. Okay, from the disk we have to copy to the main memory. Okay, we have to copy that from the disk to the main memory. DBMS often has a buffering or a caching module that maintains the parts of the database. Okay, so this buffering or caching, this is also called caching. This is also called cache or a buffer. This buffer or the cache will maintain that part of the database. Okay, that buffer will store that part of the database. This buffer will store this part. What is that part? Name of the student, that will be stored in the buffer. Okay, so this is the figure that explains this concept. Okay, hope you are clear with the concept. Okay, so we have discussed the 3 points. First advantage is redundancy, control redundancy. Okay, repetition is avoided. Second one is unauthorized access restriction. Okay, only the authorized person can access the particular data in the database. Third one is providing storage structure for efficient query processing. Okay, in that concept we have discussed about the indexing concept as well as the buffering concept. Okay, so these concepts are very important. Okay, you have to note down and study. This is not just studying the advantages of the DBMS. We are studying the concepts, main concepts. So in exams they may ask what is indexing, how a part of the data is stored, what is the concept of buffering, and all such questions can be asked. Okay, at that time you have to write these things. Okay. Next, fourth one is providing backup and recovery. See, I have told that all our databases are stored in a computer hard disk. So all of you know that the reliability of the hard disk is very less. We cannot relay the hard disk, because if any short circuit or any other thing happens, the entire hard disk will be crashed. Okay, such things are happening in every time it is happening like that. If such incidents happens, how can we restore the data? Okay, if such things happen, you have to restore the data. How can we restore the data? We can restore the data only if we are having a backup facility. Okay, so what all informations we are storing in the database, the replica of the data, replica of that data will be stored in some other hard disk or some other locations. In the if any crash or hard disk crash or something occurs, we can restore the information from the backup. That is very important. Okay, because we are having all these Gmail or Google Drive and all, we are all using this Google Drive and all. Okay, so Google is having a specialized server. In that server, all these informations are stored. Okay, informations of millions of users are stored in the Google server. Okay, so they are having a recovery mechanism. We all know that our Google server or Google hard disk is actually more reliable than our hard disk, our computer hard disk. So what we do, we will store everything in the Google Drive. Okay, so if the Google Drive crashes, everything will be gone, but it will not crash. If something happens, they have the mechanism to restore the data. So they are all backupping the data. The daily backup they are taking and storing it in some other locations. If anything happens in their server, they will copy the information from the recovery server. Okay, so that is the concept of backup. DBMS provide facilities for recovering from the hardware or software failure. So this failure can also occur due to software, not only hardware, software failure can also occur. Backup and recovery subsystem of the DBM is responsible for recovery. Okay, so the backup and recovery subsystem is the concept or the technique that is used to recover the data in case of any data loss. Okay, there are many mechanisms for backup and recovery. That all concepts we will be discussing in the forthcoming modules. Okay. So, for example, if the computer system fails in the middle of a complex update transaction, the recovery subsystem is responsible for making sure that the database is restored to the state it was before the transaction started executing. Okay, so if any complex transaction happens, when we do some money transfer or do some payments through internet, and if any error occurs in the middle, what happens? If the error occurs in the middle, even if we have lost the money, the money will be credited back to your account within 2 or 3 days. How that is happening? It is happening only because of the mechanism called the backup and recovery subsystem. Okay, so what all transactions that are happening, if the transaction is not complete and in the middle, if the transaction fails, all the previous data will be restored to the original state. Okay, even if the money has been debited, it will be credited back within 1 or 2 days. Okay, that is why we are not losing any money in case of any mobile or online transaction. Okay, so that is the concept of backup and recovery subsystem. Clear? The fifth one is the providing multiple user interface. So this database is having the concept of multiple user interface. Okay, there will be many. I have already told that a particular database is being shared to many users. Okay, it is being shared to many users. So these users can access the database in many forms using many interfaces. Okay. Suppose a programmer can access the database using this thing. This is the interface for programmers. They can write the queries or they can write the programs. Look at this concept here. Look at this statement. Select star from addressn. So addressn is the database name. Okay. So when he called this statement, when he wrote this statement, he got access to this database called addressn. Okay, so this is how a programmer access or a database administrator access, or a developer access this database. This is one interface. Okay. Another interface is like this. This is the main users. Users like us will be accessing in this interface. If we want to create a database, we can give the name of the table, okay, what all informations the database, everything we can provide, and we can click finish, and a database will be created. Okay, this is the common graphical user interface, and this one is the accessing database in the form of forms. Okay, that we have already seen in when filling some applications forms and all, we are actually giving some input to the database. Okay, so we can fill the details, and when we submit, click submit, this information will be transferred to the database. Okay, so in many forms we can, in many ways we can access, or we can interact with the database. Okay, that is the providing multiple user interface. DBMS provides a variety of user interface. These include query languages for casual users. Okay, this query language you can provide. Programming language interface for programmers. Okay, this is the programming language interface. Menu driven interface for standalone users known as graphical user interface. This is the menu driven interface. Okay, and finally it is a form based interface. This is the form based interface. Okay, in many ways we can interact with the database. Okay, this is the fifth advantage. Now the last one, the sixth one, is the enforcing integrity constraints. What do you mean by constraints? In the last class itself I have told that constraints is nothing but certain rules or certain patterns we have to follow. Okay, there are many rules we can implement in a database during the creation of the structure of the database. For example, the best example is the I have told that while creating the structure of the database, we will mention the data types and all that we have already mentioned. For example, if we are going to create a table like this, student table, before creating this table, we will be mentioning the attributes, roll number, name, department, CGPA, phone number, fee details, everything will be writing it. Along with that, we will be giving the data types. Roll number can accept integer, so we will write roll number integer, name character, department character, CGPA float, phone number integer, fee details float. Okay, such data types can be given. So giving such data type is actually giving an integrity constraint. Okay, that is, we are providing a rule, we are setting a rule for that particular database. So most database applications have certain integrity constraint that must hold for the data. Clear? So what type of data the database can hold, which is explained in the integrity constraint. The database can hold these type of data. That's explanation is given in the integrity constraint, which means that roll number field can hold integers only. Okay, so that is given, it is actually stored in that thing. Clear? Specifying a data type for each item is an integrity constraint. The first example, specifying a data type for each data item is an integrity constraint. This is the simple example for an integrity constraint. Okay, what? Specifying a data type for each data item. That is, I have already told, for roll number it is integer, name for character, CGPA it is float. Okay, for such data, for each data item we have specifying the data type. That is an integrity constraint. Another type of integrity constraint is a referential integrity constraint. So referential integrity constraint means that one field in a table can be referenced to another table. Okay, that is called a referential integrity constraint that I will explain to you. Look at this table. This is a huge database. It is having various tables: student, course, section, grade report, and prerequisite. So you just see this table. This course number, this course, okay, this course, you look at this course and section both are having a similar attribute called course number. Okay, similar attribute, which means that this course number in the course table is referring to the course number in the section table. Okay, so there is a reference. So course number in the course table is referring to the course number in the section table. Okay, similarly we have this another one is student identifier is there. Okay, student identifier in the section table, student identifier in the section table is actually pointing to the student identifier in the grade report, or we can say that student identifier in the grade report is actually referring to the we can also explain in the vice versa. Okay, student identifier in the grade report is actually referring to the student identifier in the section table. Okay, so this is called referential integrity. Okay, referential integrity, this is quite complex thing that we'll be implementing in the our lab sessions and all. We'll be seeing that concept. A more complex type of constraint that frequently occurs involves specifying that a record in one file must be related to the record in another file. Okay, a record in one file will be related to a record in another file. Okay, that is what I have explained right now. Next one is key or uniqueness constraint. This constraint specifies uniqueness on data item. That is, we are having a concept called a primary key. Okay, what do you mean by primary key? Primary key means that using that key we can identify a particular record. Okay, so we can say that in this example, the section identifier in the table section can be called as a key. Okay, which means that for using this each key we can uniquely identify a particular record, because for 85 can be is only 85 is unique, it is not repeating. So using 85 we can identify this record. Okay, so the main constraint in the primary key is that the primary key must not be repeating. This 85, is this 85 repeating? No, only 185 is there. So this is a key. So 85, using 85 we can access usually access this record. Okay, for example 102 is actually used to represent this record, CS 3320. Similarly 135 can be used to access this record, CS 3380. That is called a key. So all these integrity constraints we will be seeing in the forthcoming sessions. Okay. This is the example for our data types. We have this table, we have already seen that this is the data types with constraints we are giving. We have already seen in the last session. Student, these are the 5 tables and these are the number of columns they have mentioned. For each column, what are the data types? That is given here. Name, for name it is character, student number character, class integer, major type. Okay, this belongs to these 4 columns belong to the table student, to the table or the relation table. Here in database, table is also called a relation. Okay, so it belongs to the relation student. Okay, so these are the explanation for the 6th one, that is enforcing integrity constraints. Okay, so these are the advantage of the DBMS. So what are they? The first one is repeating, redundancy can be avoided. Okay, first one is controlling redundancy. Next one is unauthorized access restriction. The third one is provide storage structure for efficient query processing. The fourth one is backup and recovery. Fifth one is providing multiple user interface, and the sixth one is enforcing integrity constraint. Okay, now next one is disadvantage of DBMS. Okay, these are the 5 disadvantages. The cost of hardware and software, the implementation cost is very high in the case of a DBMS, rather comparing to the file processing system. This is quite high. The cost of data conversion, we have to convert the data to the required format. The database cannot accept all the format. We have to convert the data to a particular format. Okay, only that type of data can be stored in the database. So for conversion purpose we require extra cost. And staff training, we require many staff for this management and all, management of the data, this database system, and many programmers are required. So for that we have to give proper training for the staff. Okay, in order to give proper training, we'll be spending extra cost. Okay. Next one is appointing technical staffs. Okay, we have to appoint some. We can just creating a database and going away is not an efficient way. If we are creating a database, we should have certain technical staff to maintain or manage those database. We have told about that. We are having a Google server. Gmail is having a Google server, and there are millions of staffs working under the Google server for maintenance and managing this Google server. Okay, so many technical staffs are required for the management of this server. Okay, then database damage, that can happen. Okay, the database damage happens, we have to make the mechanism to perform the recovery. Okay, so database damage can happen. So these are the disadvantage of DBMS. Clear? So today we have just discussed about the advantages and disadvantages of DBMS. So please go through this. This advantage is actually covering the major concepts of DBMS. So that is why I have explained in detail. You have to write the advantage points based on the marks. If they are asking for more than 5 marks, you have to give the detailed explanation. Okay, you don't have to draw the figure, you can give the detailed explanation. Similarly, I have given. Okay, so this is called the advantage and disadvantage of database management system. Okay, thank you.